Hello and welcome to Unit 10, Redox, Lecture B. Today we're going to talk about half reactions. So our first step when we look at an equation is to decide whether it is redox or not, and we have to assign oxidation numbers to do that. So we have some examples here. There's the four different inorganic reactions that we know. So synthesis, pure potassium is oxidation number 0. Pure chlorine, 0. In the compound now, they're going to pick up charges. So potassium's in group 1, he's +1. To make this a neutral compound, that makes the chlorine -1. Again, we're focusing on oxidation states, not total charge. This pure element being 0 is probably the one you will mess up first. If you don't remember how to assign oxidation numbers, go back and watch Lecture A. If we look at this, potassium is going from an oxidation number of 0 to +1. So his oxidation number is going up. If it goes up, that is oxidation. Chlorine's number goes from 0 to -1. His number is going down. Down is reduction. Oxidation is loss. Reduction is a gain of electrons. The numbers go up or down. This is redox. Decomposition. Here we have mercury oxide. We need to know which mercury this is. There's mercury 1 and mercury 2. Oxygen, when it's in a compound, is almost always -2, which makes this mercury +2. Pure mercury 0, pure oxygen 0. If I look at what's going on in here, mercury goes from +2 to 0, so his number has gone down. That is reduction. Oxygen's number went from -2 to 0, so his number went up. Remember, negative to 0 is up, so the oxygen has been oxidized, and again, this is a redox reaction. Single replacement, pure calcium is 0. In hydrogen bromide, bromine is a halogen, so when he's negative, he's -1. That makes the hydrogen +1. Calcium bromide, again, the bromine is a halogen, so when he's negative, he's -1, which means the calcium in group 2 is +2. Hydrogen is 0. So calcium's number went from 0 to +2. That number went up, so that's oxidation. Hydrogen's number went from +1 to 0. That number went down, so that is reduction. So this is a redox reaction. What about the bromine? Bromine went from -1 to -1. There's no change. He is what we call a spectator ion. So he's just kind of along for the ride. He's there to make the compounds neutral. And as far as redox is concerned, he is not changing at all, so he's not part of our redox equation, and so they call them spectator ions. Sometimes you'll see what they call the net ionic equation, and in that case, they would just write this as calcium plus the hydrogen ion turning into the calcium ion plus the pure hydrogen, and it would look like this. Obviously, this is not a complete equation because we can't just have positive ions floating around out there without something to go with them. That would break the law of conservation, but this is called your net ionic equation. And sometimes they will just take the spectator ions out so that they don't confuse you. Last but not least, we have double replacement down here. Hydrogen's +1 makes the chlorine -1. Sodium's in group 1, so he's +1. Oxygen almost always -2. The hydrogens are +1. Sodium group 1 +1. Chlorine halogen -1. In water, hydrogen +1. There's 2 of them. The oxygen's -1. Nothing changes. So if there are no changes in charges, this is not redox. Double replacement reactions are never redox. The other 3 might not be redox. They might be redox. You have to assign numbers to find out. Double replacement are never redox. Never. Because there are 2 parts to a redox reaction, the reduction part and the oxidation part, a lot of times we are going to pull out those 2 halves and write them as 2 half reactions. So if we look at this full equation here where I have calcium, which has an oxidation state of 0, and fluorine with an oxidation state of 0, in calcium fluoride, it's going to be +2 and -1. The calcium is going from 0 to +2, so we write that half reaction. So from 0 to +2, in order for this to be balanced, I have a charge of 0 on this side, I have a charge of +2. We need to make this balance to obey the law of conservation. So 2 electrons on this side gives me a charge of -2, +2 plus -2 gives me 0. So this equation essentially says 0 equals 0. This is oxidation because the number went up. Oxidation is a loss of electrons. If it's losing electrons, electrons are a product over here. The number of electrons lost is how many it had to lose to become that ion, and it's going to add up so that our charges are balanced. It obeys the law of conservation. The fluorine, notice that I kept this subscript. The only subscripts you will keep are for diatomics. Anything else, you're going to ignore the subscripts. Only take the subscripts for the diatomics. They have to come in sets of 2. You have no choice. Anything else, leave them off. Notice over here when it's an ion, I don't use the subscript for it. I put a coefficient in the front so that, again, it obeys the law of conservation. So if I have fluorine at 0 on this side, and I'm adding 2 negative electrons to get my 2 fluorines that are -1 each on this side, I have a -2 charge equaling a -2 charge. It obeys the law of conservation. Going from 0 to -1 is reduction. The number went down. Reduction is a gain of electrons. So if I'm gaining electrons, electrons are a reactant, and they're over here on the left. Again, the number of electrons you need to gain is going to be however you need to make your oxidation numbers balance, and the charges have to be the same. Let's look at writing these from a real equation. So if I'm going to write one over here off to the side, let's just do the half reactions for making water, which we looked up there as a synthesis reaction. We have to make sure that it's balanced first. And then we assign oxidation numbers. So the hydrogen 0, the oxygen 0, the hydrogens are +1, the oxygens are -2. We're going to pull out our hydrogen. Hydrogen's diatomic, so I have to keep the subscript 2. He changes into hydrogens that are +1. I need to get this to balance. 0 to +1 is oxidation. That number went up. So electrons are going to be a product. I have 2 hydrogen atoms and only 1 hydrogen ion, so I'm going to need 2 ions. 0 equals 2 times +1 is +2, so I'm going to need 2 electrons. I double check my numbers, 2 hydrogen atoms, 2 ions. 0 equals +2 plus -2, 0 equals 0. That's the half reaction for the hydrogen. Oxygen, again I'm going to keep the subscript because it's in its pure form, is turning into oxygen -2. This is reduction because the number is going down, so reduction is a gain of electrons. We're going to gain electrons on the left side. 2 oxygen atoms means that I need to make 2 oxygen ions. 2 times 0 is 0, plus a -1 equals 2 times -2. That's a total of -4. That's 0, so that means I need a total of 4 electrons. 2 electrons for each oxygen atom to become -2 ions. 2 oxygen atoms, 2 oxygen ions, -4 charge on the left, -4 charge on the right. -4 equals -4. That's a balanced half reaction. When we balance full redox reactions, we have to account not just for the number of atoms, but also for the charge. They have to obey the law of conservation of both mass and energy, so the charges are going to become important. So if we look at the net ionic equation here, where I have lead +2 ions and gold +2 ions, equaling lead +4 ions plus pure gold, obviously there's 1 lead and 1 lead and 1 gold and 1 gold, and it looks like it's balanced. But because this is a redox equation, and we don't have the spectator ions included, it's just the net equation, then we need to make sure we are balancing for charge as well. So your first step is to write the half reactions. So lead plus 2 turning into lead plus 4. The number went up, so it's oxidation. So my electrons are going to be on the right-hand side. Plus 2 equals plus 4 plus minus 2. To go from plus 2 to plus 4, you've lost 2 electrons. So I have 2 electrons on the right. My gold has gone from plus 2 to 0. To go from plus 2 to 0, you need to gain 2 electrons. It's reduction. Reduction is gain. So there's my oxidation, and here's my reduction. I recommend labeling which one you think is oxidation and which one is reduction out of habit. And we have to double check to make sure this is obeying the law of conservation. So we look at the electrons gained and lost. It's lost 2 electrons, it's gained 2 electrons. This is a balanced equation already. So the coefficients just stay, and they're all 1. And so the coefficient on the lead plus 2 is 1, and that's not a problem. Let's look at the next example. We have pure magnesium and chromium plus 3 becoming magnesium plus 2 and pure chromium. So pure magnesium, which is 0, becomes magnesium plus 2. To become plus 2, you lose 2 electrons. Chromium plus 3 becoming pure chromium. To go from plus 3 to 0, you need to gain 3 electrons. Oxidation is loss, so the magnesium is being oxidized. Reduction is gained, so the chromium plus 3 is being reduced. And now I check for the law of conservation. It's losing 2 electrons, it's gaining 3. Where did the extra electron come from? We don't know. It's not magic, it's chemistry, so we have to account for that. We look for the least common multiple between 2 and 3. Least common multiple between 2 and 3 is 6. So to get 6 electrons lost, I need to multiply this entire equation through by 3. 3 magnesium atoms will have to make 3 magnesium ions in order to lose a total of 6 electrons. This equation then will have to get multiplied through by 2. 2 chromium plus 3 ions will have to gain a total of 6 electrons to become 2 chromium zeros. Then these coefficients are the ones that go into place. So where there is magnesium 0, we put a 3. Where there's a chromium plus 3, we put a 2. Where there's a magnesium plus 2, we put a 3. And where there's a chromium 0, we put a 2. And then this question wants the sum of all of the coefficients. So 3 plus 2 is 5, and 5 plus 5 is 10. More likely what you're going to see on your final is a multiple choice question that wants to know which one is balanced correctly. So remember that redox reactions have to be both balanced for mass and charge. So what I want you to do first is check for mass, because you've been good with that already. There's 2 chlorine atoms, there's only 1 chlorine ion, that one can't be right. There's 2 chlorine atoms, there's 2 chlorine ions, that's okay. 2 chlorine atoms, 2 chlorine ions, that one's okay. 2 chlorine atoms, only 1 ion, that one is wrong. So now we're down to 50-50, and we have to check charge. 2 times 0 is 0, plus 1 electron, so we're adding -1. The arrow is your equal sign. 2 -1 electrons is -2. So I essentially have -1 equals -2. That is not equal, so that one must be wrong. We're going to double check this last one just to be sure. 0 plus 2 times -1 is -2. The arrow is your equal sign. 2 times -1 each is -2. So I essentially have -2 equals -2. That's correct, and B is your answer. So take it one step at a time. Look for number of pieces first. That's your mass. Then check your electrons for the charge. They have to obey both. That's the law of conservation. And that's it for Lecture B.